Got about 2 minutes or so, so if y'all can hear, we'll just maybe do that audio background if that's okay. That way it won't be such a surprise.
So Liz, I got your message that this is a webinar. We won't be seeing any folks.
Right.
And we go from 9:30 to 10:15. Is that correct?
That's correct. They'll be able to ask questions in the Q&A,
Yeah.
but we won't see their videos.
All right, I'm about to get started.
Awesome. Welcome everybody to the Wisconsin Science Festival field trip. And thank you for joining us today. My name is Jo Withers from the Wisconsin Science Festival team, and we're here with Tom and Liz. You will notice that your pictures and audio are muted, but we do encourage you to ask questions using the Q&A feature. So whenever you have those questions in your head, go ahead and type those into the Q&A feature or have your teacher do it. This field trip is recorded, and as always, we ask that you do this in all activities with the Wisconsin Science Festival with a responsible adult. I want to thank all of our sponsors and partners that help make the festival possible. And you can join more activities and events during the festival at wisconsinsciencefest.org, including joining the Wisconsin Science Festival BioBlitz. So with that, I'm going to hand it over to Tom and Liz.
Thank you very much, Joe. Liz, would you like to introduce yourself?
Hi, everybody. Yeah, I'm Liz Jesse. I'm an science outreach specialist, and I normally work where Tom is at the Biotechnology Center, but this morning I am home. So some of you might be home, and some of you may be where I am. So we'll be kind of doing things in two different ways today. So that'll be kind of fun.
And I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center along with Liz. This is our outreach lab. You can see the places that we work for include UW Extension and Wisconsin 4-H, which is part of the University of Wisconsin-Madison. So we're delighted to be able to share some of our science with you. If you would like to come and visit us sometime. Liz, do we do field trips?
Oh, we do a lot of field trips. We're kind of like a science outfitter around here. So you can talk to your teacher, or your school, or your parent, or your Girl Scout group, or your Boy Scout group, or whoever. And if you want to come spend an hour, 6 hours, however long you want with us, we can get you to a bunch of different locations, science locations on campus, from the Geology Museum, Biotechnology Center, DC Smith Greenhouse. We can go see the ants at the Microbiology Building. There's a lot that we can do if you want to come visit us. So come on down.
One of the places we can go see is the Dairy Cattle Center. There's about 84 cows that live on campus. It's part of the research herd here at UW-Madison. We have more cattle at Arlington and other places around the state. But cows give milk, and one of the most pressing questions ever has been, which makes better bubbles, skim milk or whole? Which makes better bubbles, skim milk or whole? So there are a lot of different ways that you can approach that question, that puzzle. What are some ways that you could address that question, that puzzle question? Liz, have you ever taken a vote on something?
Yeah, I've definitely voted on things.
And would that be a good way to approach this, which makes better bubble, skim milk or whole?
It could be. That's one way to do it. I don't know if that's a scientific way to do it. I mean, if I was a data scientist, probably.
Yeah,
So
I would tell you what that could give you good evidence of what the population thinks about point blank, what makes better bubbles. Could you take an opinion poll?
Absolutely, you could. Opinion polls are all right, but I don't know. Opinions can change depending on things, right? Opinions can be skewed or changed depending on what somebody may tell you. So yeah, I don't know. That's also, but that is data. You're right, Tom. That's one way to do it.
Another thing we could do is try to remember if we've ever had a chance where we've either blown skim bubbles in skim milk or in whole milk, and we could try to think about what had happened.
Yeah, past experience is huge, right? I think scientists use that often. Like sometimes they just look at observations. Everyday observations can lead to a lot of things in the lab, right? So looking back at, as far as you want to go, you can really collect a lot of data from your memory and use that background knowledge.
And another thing you can do is look it up, see if somebody's already done this. So that's great. But for our purposes today, what's the best way we can do? What's the thing that the approach that we can take to ask which makes better bubble, skim milk or whole?
Could we ask the milk?
Let's interview the milk. So for this, we need how many types of milk? Two?
2.
All right. And those are going to be, go ahead.
I was going to say, just a quick note. I know that everyone was given a list of materials that they need, but no big deal if you couldn't get them, or if you're just here and you're like, I don't have materials, Tom and Liz, what do I do? That's fine. You can watch what we're doing. And then what's great about science is reproducibility, right? So we may do it today as a group, and if you have materials, you're going to do it with us as a group this morning. But hey, no big deal. If you don't have it, when you go home, go in your kitchen, find some cups, find whatever milk you have around, and then you can do it later. So just a quick note, it's okay if you don't have the materials, you can do this later as well, if you can't do it with us right now.
All right, so we've got skim milk and whole milk.
Ooh.
How many cups are we going to need, Liz?
Well, if we have 2 types of milk, generally I'd probably say we would need 2 vessels to hold that milk or for us to blow bubbles. So probably 2.
And if we're going to have 2 plastic, you got 2 nice clear plastic cups there, so that's really helpful. They don't have to be clear in plastic.
No.
But what are some advantages of having clear in plastic cups?
Well, and I can see inside of it very easily, right? Otherwise, I'm looking, on top of it. It's a little hard to see what's happening underneath the milk while I'm doing this if you have a solid cup. So
So
And we did do it. We did a quick poll with our panelists, and about
Oh, yeah.
100% are saying whole milk are going to make better. So
Goodness, these are good Wisconsin people here. It's-
they want the whole milk.
what the- oh,
So we are
oh,
taught, right?
wow.
So yeah, clear cups are
All right.
good. But also, kind of an important, how are you gonna, if your cups are identical, mine are identical,
Mhm.
how am I gonna know which milk is which when I put it in there? Because I don't know about you guys, but all milks kind of look the same to me. I mean, there's some little differences, yeah, but how am I gonna know if they look the same?
So, well, a couple of approaches might be placement and just to mark a little thing on the table where you are and say S for skim and W for whole, or you could mark the cup itself, and that's pretty cool. But the key thing is you got to treat the two things fair. So if you mark one cup, you got to
Mark the other one. So we
Okay.
want to have as few variables as possible, Tom, right? A variable is a difference in the experiment.
So we want to make it as fair as possible. Okay, so now we've got skim milk, whole milk. How much milk goes into each cup?
That's a good question. Maybe we should ask the group what they think.
So if you're gonna say, got to have some skim milk in each cup, excuse me, a skim milk in one cup and whole milk in another cup. If you're going to design the experiment, you have to figure out or decide at least how much milk goes into each cup. And you might think like, oh, this is pretty straightforward. And it kind of is, but what are some of the things that folks might think?
Anybody want to throw in the chat? How much milk should we be using in each cup?
Nobody has yet.
So this is a weird thing because we're asking how much milk goes into each cup. And yet the only right answer, as far as I know, is the same. And that doesn't address how much, but the key thing is however much skim you put in, that's how much you got to put in the whole cup and vice versa. And this is again back to what Liz was mentioning about the issue of fairness. Whatever you do for one, you got to do for the other. Now think about what it's going to take if you do 1/3 versus 1/2 versus 2/3 versus right up to the brim. If you like to make a mess and if you like to clean up a mess, going right to the brim might be the thing to do it in. But I'm going to suggest we do about 1/3 because that gives you some head space, allows you to see the bubbles within the cup. And if you want to make a little ice cream cone and stop, you can. If you want to make a milk volcano, you can, but then you get to be a volcanologist and clean it up.
Mm-hmm.
All right. So Liz, do you want to show folks what you're about to do? And I'll try doing it on my side also.
Yep. So I have my cups labeled because that's just how I am. So I'm going to add, it doesn't matter what size cup you have, right? Mine are about 3 ounces, but it doesn't really matter. So I'm just going to start with one. I'm going to take it about 1/3 of the way. And then I'm going to grab the other one. And I'm going to get down kind of low with my eyeballs so I can kind of make sure that I can see. Oh man, that's on my face. So I can see. Oh, interesting. Go ahead, Tom. I have to mix my milk up a little bit. So
Okay.
I used instant milk because I'm a vegan actually, and I don't drink milk. So I have to use powdered milk when I do this. And I did this last night and I had some chunks that didn't quite dissolve. So give me
All
one
right,
second to mix my milk. Why don't you show yours, Tom?
All right, I'm going to switch over here. Let's see what we got here. All right. So right here's my whole milk. Here's my skim milk. And then how many straws are we going to need?
Well, how many cups do we have?
2.
Okay. Well, I mean, you all are your own scientists and you're designing this experiment on your own. We're kind of doing it together, I know, but I would probably have 2 cups or two straws, excuse me, because I want to have 1 straw for each cup.
Well, okay. Now, if I only have 1 straw, what can I do and still make it fair?
You could probably cut that straw in half.
Way to go. So part of this is people want to save on supplies, and I'm all for saving on supplies.
Absolutely.
But you also have to balance saving on supplies with making sure it's fair. So here we go.
Now, Tom, why don't you hold on? I see you have clear straws. I have colored straws that are a bunch of different colors. And everybody at home, you may have colored straws as well, right? So do you think it matters what color straw that I'm using?
Well, as a scientist, I would say I don't really matter what I think. It's can I test it out or can I make it not a difference? So if you have enough straws, you have several straws of several colors. If you want to make it not a difference, what can you do?
I can just make sure that I have the same straw. So if I'm going to use yellow, I'm going to use 2 yellow straws.
Okay. So one of the cool things about experimental design is saying, well, we don't care one way or the other, but let's make it not a difference. And that's just getting very attuned to what's fair and what you can do as a scientist to make things fair. All right, Liz, how's that looking for you?
It's looking good for me. I got about a third on each. And I don't know, I'm just looking at milks in general and how they're looking.
Yep.
And my whole milk, all right, I gotta swap these actually. My whole milk, it's on my left side, is looking a lot thicker than my skim milk.
All
I
right.
don't know if it's gonna make a difference at all, but that's just kind of what I'm looking at observations here, and I'm also seeing that my skim milk, like neither of them really have a color, but the skim milk looks a little more like bluish, and my whole milk looks a little more like white.
All right. So we can already see a difference in the milks even before we start blowing.
Right.
Now, am I going to blow? I got my straws all set to go.
Okay.
I'm at a fork in the road here. Am I going to blow one straw and then the other, or blow both straws at the same time?
That's a good question. And I think as a scientist that is putting together this experiment, I think you need to make that decision on your own. But you don't have to actually make a decision. You could do both though, right? You could try both ways.
So one of the cool things about getting to design your own experiments is sometimes when you come to these forks in the road, the proverbial fork in the road, you take it. It's like when my mom used to ask me, do you want chocolate ice cream or vanilla? And the only right answer for me was both. So there's nothing that says you can't do this one after the other and then try it both ways. Because this is, if you go to blow this, you got to figure out, are you blowing fairly into both of them? So here comes my skim.
Oh, you're doing separate. Okay.
Yeah, to start with.
I'm going to do them at the same time. So I think now is the time for, if you have your milk all ready to go, and if you have your straws all ready to go ahead and run this experiment yourself. However you want to do it, blowing both straws at the same time, like I'm going to do, or blowing them separately like Tom did. So go ahead, everybody take a couple seconds here to start your first trial.
If you don't have milk, start looking at mine, and then you can also look at Liz's and start seeing when we say which makes better, bubble, skim milk, or whole. Here's some of your first evidence.
So this is my whole and this is my skim.
And of the 9 people who voted, all 9 said that whole was going to be better, or they thought it would be.
Mhm.
And that's great, but here we have the actual milks here going. Now I'm going to blow them again. Oh, by the way, what are some differences that are you seeing, Liz?
I'm seeing that my whole milk, the bubbles are not clear, and in my skim milk the bubbles are very clear, like I can see right through them. Let's see, the whole milk bubbles are larger in size and in like diameter, and the skim milk are smaller. I'm seeing that so far. Now I don't know about you, I kind of want to start from scratch. So I think Tom's waiting a little bit, so I may kind of like pop my bubbles a little bit just to get back to status quo, so that I can kind of start things, because I may want to start to think about things like time, like how long is it taking for the bubbles to both get to the same height? How long is it taking them for them to pop all the way? So I want to kind of start at a base level so that I can blow them up again, and then I can do those same observations again, or maybe some different characteristics that I'm looking at as well.
So I'd also like to point out what Liz just did with her fingers. I'm going to ask a bad joke alert number 1. What is the state folk dance of Wisconsin? The polka. So can you please check, did Liz just test the pokeability of the 2 bubbles with her fingers?
I did, but I wasn't really paying attention that closely though.
That's still pretty cool. Okay, so I'm going to blow mine again. Oh, by the way, which bubbles lasted longer?
My skim lasted longer.
Okay, here we go. Now I'm going to blow both at the same time. And I'm doing the ice cream cone approach, where I blow so far, makes a nice little mound, and then I stop. That's in contrast to the milk volcano, because I don't want to have to be a volcanologist and clean up.
Plus, it's hard to really tell when your bubbles are just flowing all over the table. That's a little more difficult to collect your data.
So we're seeing on the second time around, and scientists repeat their stuff. I see my whole milk is really pretty cloudy. The skim milk is clear, and the bubbles are lasting longer. And now I want to do strength. I don't know if you notice it, but my straw on this is just about to hit the rim on the right-hand side. The milk hit it all along. So we're going to ask, can you invent a way to test the strength of bubbles? And what we're going to do is use the straw. We're going to call this standability. Standability. So now I'm going to intentionally blow bubbles about the same. I'm going to have a little race here. And
So
letting the milk talk to us.
that whole milk did not last
There.
very long.
Yeah. And what's
Skim
cool
milk
about this
almost-
is, we've been doing this for a while, and when the students that we were working with first did this, like, wow, that is really something that they used. What did they use? They used what they had right at hand, literally at hand, and they used the straw as a device. They invented a tool. They invented a measuring device. So there's the first run, and the milk is my skim just fell, but it fell after the whole milk. I'm going to try that again. Liz, what are you seeing?
Yeah, it was. I'm on my second trial as well, but yeah, the whole milk, they're pretty weak bubbles.
So I did have a student ask, can you test more than one thing as far as what makes a better bubble?
So kind of getting into what is better. We're testing a lot of stuff, right? So yeah, you can definitely test as many things as you like.
So this is actually one of the key things about this experimental activity is getting to the point where somebody first raises their hand and says, which makes better bubble, skim milk or whole? Well, what do you mean by better? So as a scientist, does it matter how you frame your questions?
Yes.
And if you ask a poorly framed question, or at least in this case, an ambiguously framed question, ooh. So one of the things we're doing with this activity is to help train your brain and your ear to hear when somebody asks you an ambiguous question. In this case, it's which makes better bubbles, skim milk or whole. So hopefully for the rest of your life, if somebody says, oh, this is better than that, or which makes better this, A or B, I hope one of the first things you'll say is raise your hand and say, what do you mean by better? This construct, A is better than B, is used all the time. And as a scientist or any well-educated person or any person who's got some skepticism in them and a little bit of show me mentality, this is a great thing to develop. So Liz, instead of asking which makes better bubble, skim milk or whole, what can we do? How can we reframe that?
That's a good question. Maybe we could frame it as, well, what's actually, well, I mean, I guess we should talk about what's actually causing like, is there any difference between these milks that would maybe be causing the bubbles to be different?
Well, then we're switching the question from which makes better bubble, skim milk or whole to the idea of does milk fat, the only known difference in composition is milk fat.
Do you have milks in front of you, Tom, the containers that you can show? I think
Why,
he's-
yes, I
okay.
do. Let's see if I can switch cameras here.
Okay, or you can also put them down low underneath where your milk is too.
Oh, there we go.
Nice.
Okay.
Okay.
Oh, it's like a microscope. I have to go the opposite direction.
That's
So what
okay.
is this reading all right there, Liz and Joe?
Yeah, we can see it.
Okay, so this is a fat-free milk. We call it skim milk. It's actually sold in Wisconsin as fat-free and not as skim. And if you look at there, you'll see how much total fat is there.
Let me see if I can get closer. Well, it's fat-free, so I'm assuming that the answer is 0, but now I see that it is 0 grams.
Yep. And then this is whole milk. which is also sold as whole milk. And let's see if you can see what that is
I believe it's 8 grams of fat in per cup,
per cup, and the cup is
8 ounces.
yeah, it's a regular cup, 8 ounces.
Yep.
Okay, so what we're actually testing here is what's the effect of milk fat on bubblicity. And so when we go to reframe that, now we got to redefine, or we get to redefine all the different characteristics, many of the ones that you already mentioned, Liz. So we're going to have a lot of them. It's going to be speed, clarity, size.
Wait. Can I write these down, Tom, in something that may help me organize my thoughts a little bit? Can I put my data in something?
Yep. Can I ask Joe for permission to ask a bad joke?
You have my permission.
Good. Most tables have 4 legs. Some tables have only 1 leg. What do you call a table that has no legs? A data table. So one of the big ideas, as Liz was just alluding to, is when you have a lot of data as a scientist for your own personal insight and to share what you're finding with other people in a fast, coherent way, sometimes you want to put things into a table. And what is a table? Sometimes a table is a big piece of wood, but in our case, it's a little piece of paper, and Liz has made a table there. So Liz, what's your table say?
Mine just says qualities, like the qualities that I'm looking at. So you can call them characteristics instead. You can call them whatever you want, but I'm going to list those here. And then I have an S for skim and I have a W for whole.
And we're going to, sometimes you can call them traits.
Traits.
Maybe we can get up to 8 traits. So what's the first one, Liz?
Well, the first thing that I saw was clarity and how clear the bubbles were. So I'm going to write down clarity as one of them.
Okay. And then Joe, if you can ask the folks who are watching if they have any suggestions on what characteristics or traits they remember and others that we might be able to test, that would be wonderful.
Yeah, and as you're doing that, I think also as you're talking about sharing data, this is really important for science, right, Tom? And this is why communication is really important. And this is one interesting thing that if we're talking about, I don't know, like finding the length of something, like being able to have standardized things that we can and units that we can share is really important, right? Because if I'm a scientist in the United States and I want to share my data with a scientist in Japan or somewhere in Europe, we have to be able to communicate in the same like scientific language, right? So it's important to think about, easy ways to communicate well.
So we have qualitative things like how milky it is, but we could also measure how
Well,
high.
Jennifer suggested size.
Yes, size.
Size. I will write that down.
Jennifer, does that mean size of the overall mound or size of individual bubbles? Or can we do both?
Individual bubbles.
Jennifer Jennifer said individual, and then she said or both.
All right, so let's make 2 different characteristics there. One is the size of the mound, and the other is the size of individual bubbles.
Okay.
So what's your table look like now, Liz?
So far, I only have 3 things.
All right.
Aaron has suggested lasting ability, which I think maybe means how long, how long the bubble lasts without popping.
Like duration? Can I
Yeah,
just call it
I like
duration? Okay. Duration. Go ahead. Sorry, Tom.
What are diamonds famous for?
How hard they are.
True. But also a C word.
Their clarity.
That's what I have first. Clarity was my first thing that I had.
didn't see that.
Oh, boom. Strength. Somebody just said strength. That's good.
Yep.
Would we call that? I guess, Tom, you would call that pokeability, but yeah. I think
no, there's 2 different types of strength. One is pokeability and the other is standability.
Oh, okay. Okay.
Okay. And then next one will be a little different, and that's going to be, can we inflate and deflate a bubble? So say inflatability.
Okay. I should have gone the other way on my data table because I am running out of space.
Okay. And the last one I can think of is swipeability.
Okay.
So let's look at all these things now. I'm going to do it again. Can you do yours, Liz? And we'll
Yeah.
check which one there.
Okay.
Here
you
we
wanna-
go.
So are we gonna test? We're gonna go back and test clarity and size, or are we gonna go down to some things that we haven't done yet?
I'm going to do it all.
We're gonna
What
do
is swipeability?
Yeah, we should probably talk about swipeability, Tom. We have not talked about that yet.
All right, what is swipeability? Well, first of all, here's size. And this is cool about it being 2022 and everybody has a camera.
Tom, you made a flip here. Can you flip it so we can see your bubbles?
Thank you.
Keep
All
you
right.
on your toes, Tom.
I forgot about my camera. Okay.
We have another suggestion of reflection or refraction.
Wow, that's a completely new. I've been doing this since 1992.
That's a good one.
Write that one down.
Okay.
Okay. So here we go. We've got a whole bunch of things here. Overall size of the individual bubbles. We can take pictures and then analyze those if we were really good. Here's my standability. The whole milk straw just fell over. And for people that were wondering what swipeability is, that's when you go like this.
It looks like they actually hang on to the straw.
Some of them do, and the straw can go right through when you put the straw across the rim.
Could you use a timer to check on that lasting ability?
Yes.
Absolutely.
So there's the swipeability for the whole milk. You could also do liftability. And if you're a barista and you're working with milk as part of what you're doing for making drinks with coffee, and you're foaming, all these things are cool aspects of this that are not just trivial. So
I just read an article recently that a lot of baristas like Starbucks and whatnot and coffee places are actually putting powdered milk into their regular dairy, into their liquid milk already to increase that foaming of
wonder if that's powdered non-fat milk or powdered with fat milk.
Good question, because you can get both, because I use both. You can, I'm assuming it's, I don't know, I guess it depends on what kind of milk the people are asking for. Because if they're asking for non-fat, they don't want to have that full fat powder put into their milk.
We have an attendee that said the swipeability looked like magic in the whole milk.
Like
It wasn't moving the bubbles.
Yep, goes right through it. Okay, so Liz, have you been able to fill out your table?
Not so much, because I've been doing my test.
Okay, so while we're doing this, let's stop and think about what we've done. We've started with a question, which makes better, bubble, skim milk, or whole? We took a poll. People had a chance to give their prior impressions of what it would be. Of the 9 people that shared, all 9 of them said whole milk because, hey, Wisconsin and whole milk is better than skim milk. And, or at least that's what people often are taught. And that might be for some things, but for bubblicity, is it enough just to take a poll? Is it enough just to think about it? Or is it the kind of thing that you want to go and test? And so this is one of the things that we do with as being a scientist. We don't just think about it. We don't use just logic. We don't use solely opinion polls. We go out and we interview the milk. We ask the milk. We do the fair comparison. And then who's in charge of making sure everything's fair? You guys are. And then we had to hear that, whoa, this question isn't exactly all that good of a question. And so part of this is training everyone to be able to hear when you're asked an ambiguous question, because you have to come up with strategies when somebody asks you an ambiguous question, especially if it's somebody in a position of authority. And because then it's like, whoa, wait a minute, what do you mean by better? And if that person in position of authority tells you what they mean, that's great. But if it's like you ask your boss something and you're sitting there going, you realize, oh, this is an ambiguous question, but they walk out the room and they're not there, you may have to decide what to do about this ambiguous question. In this case, which makes better bubbles, skim milk or whole? So what we've been able to do is say, well, let's reframe the question and say, what's the effect of milk fat on bubblicity, and come up with all these different characteristics, these 8 traits that we're looking at of how milk fat affects bubblicity.
Hey, Tom, did you test inflatability? I don't think we ever really talked about that one. Or
Let me show you what inflatability is. You take a bubble like that and then stick your straw in here and go like this.
Oh, Tom, can you move your camera? Can you switch your camera? Sorry.
It's not easy being a genius.
I know, I know.
Oh, Tom, you have it turned off now.
Turn it off.
There we go. We're good. We're good.
Oh, good. Oh, boy, it's not like we haven't been doing this for the last 2.5 years. So here's a little straw or a little bubble. I just put my straw in there, and this is a lot like, Liz, why don't you talk to folks about what Kathy Krentz does?
Oh, so our colleague Kathy Krentz works, her kind of whole job is to inject embryos with small pieces of DNA. So she takes a really thin, long needle, and this is what she does all day. She sits at a microscope and she has a little embryo, and she takes a thin needle and she puts it into the embryo, and then she kind of injects that DNA, and you can kind of, she knows that it works because she can see it swell a little bit to know that it's been added correctly. So yeah, you're kind of injecting air into your bubble, not little small segments of DNA.
So I don't know how well this is. Let me try it closer to the camera. Liz, if you can guide me, because I'm got to look at like this way.
That's good.
Yeah. Okay. Ooh, that's pretty strong. Is that your
So that was
skim?
go ahead.
That was your skim milk, right?
That was a skim. Yep.
Okay. Ooh, doesn't seem to work quite as well with your whole milk.
But that issue that you can really do some interesting tests of the strengths and weaknesses of the bubbles and stuff, even though, you know, this is just milk. And one of the great things about this set of experiments is it's with doing stuff with food is great because it's familiar, accessible, inexpensive, and safe.
Sorry, Joe, go ahead.
We have a class that's asking, can you have you done this with other liquids?
Well, yes, we have.
And that may be a good experiment for you you can kind of take what we've done today and go home tonight, and you can run it with your families. And you can use whatever you have in the fridge or whatever, yeah, you can use different. Oh, Tom's got chocolate milk. Spoke too soon. He's already doing it. We've done it with chocolate. We've done it with strawberry. We've done it with non-dairy milks. You can try a lot of different things. Go ahead.
Oh, you could do like almond milk, right?
Absolutely. Almond, soy, yep, goat milk, another type of ruminant. That's a ruminant, right, Tom?
Yes.
Okay.
So what's cool about that question is the mindset, the skills that you develop with this are really applicable to any other thing that you'd like to set up. It's like, how are we going to set this up in a fair way? What characteristics are we going to look for? How are we going to, and the things that we can measure, how are we going to measure them? Now, here's one of the difficulties with the chocolate milk. There's only one known difference between skim milk and whole milk in composition, and that's milk fat.
Mm-hmm.
But when we look at
I was gonna say, show the container of chocolate
milk, holy cow.
There's a lot of ingredients in there. There's cocoa, there's sugar, there's a lot of things that could be affecting it.
We can do the characters, we can do the comparison and say, oh, here's how we can add a third row to your table, skim milk, whole milk, and chocolate milk. We could get strawberry milk and have a fourth row.
Oh, you're looking a little wild.
But what's cool about the first one is because it's only one difference in composition, we can assign cause and effect, that the milk fat is the likely cause of all these differences in bubblicity. With chocolate milk, can't do that. We can't assign one sole characteristic. We could try to add things one at a time if we're a food scientist. And that's one of the cool things about being a food scientist, is that's the kind of work that you get to do. Now it's 10:07, Liz. The last thing that I think people are going to notice when they go to do this, well, why don't you try blowing your bubbles now?
Okay, I know, they,
And I'm
okay.
going to blow mine.
And you can all do it as well, like, try it again, run a trial now, because what we started at about 9:30 and it's now 10:07. So let's try it again.
And we have a group who's saying, thank you, great discussion of experiment design.
Thank you. That's what this is about. It's not about milk. It's about getting to use your head and your hands to compare things in a fair way so that you can test your ideas.
Well, I don't know about you, but my whole milk is barely even, let the bubbles start and they immediately pop.
Yep.
And my
So what
skim
are
is,
some,
my skim is behaving better than my whole for sure.
so what are some of the things, Liz, or anybody, Joe, if you want to invite folks, what are some things that milk has experienced over the last 20 or 30 minutes? Because those are the kinds of things that we might want to test, as to try to explain why it is that the bubbles are behaving differently now than when we started.
Yeah,
Has time changed anything?
yeah, Joe, that's a good question. Like, yeah, think about it that way. Has time changed anything as your cups have, or as your milk has sat there? It's definitely had more exposure to the cup, which could make a difference.
Yep. So then you'd have to set up.
Well, because it's warmer.
Yeah.
So the cool
Or I
thing.
wonder, could it have coated the cup at all? And would that change anything?
Yes, and how would we test that?
Hmm.
So part of this is time course studies where you'd have to set up sets of cups where you add the milk 20 minutes ago, but don't blow, 10 minutes ago and don't blow, 5 minutes ago and don't blow, 1 minute ago and don't blow right now. And then you blow in all 10 of them to see whether the dwell time in the cup makes any difference. Temperature, how could we test whether temperature makes a difference?
Get a thermometer out.
Well, does thermometer tell us what the temperature is?
Yes.
Well, would that necessarily tell us that the temperature was a thing that mattered?
Not necessarily.
So it could tell us whether it would change. So we'd have to say, well, we measured it back 30 minutes ago, and now we measured it. We noticed that it's warmed up. But does that tell us that that's what happened? That's the key thing. So let's use.
So you could. What if you kept it in ice the whole time?
Yeah. So let's use some if-then speaking and thinking. If-then are really powerful tools, words and mindset. So if you want to test whether whether temperature affects bubblicity, would it be nice to have some milk that's cold and some milk that's at room temperature?
Yes.
And how do you do that?
Well, you could. Well, I guess you could get a water bath that is room temperature, so that you maintain. Okay.
So here, if you have something as simple as these trays, what am I going to put in this one?
Room temperature water.
Yeah, or warm water. Yep.
Or warm water, and bring it to room temperature, or whatever you're looking at.
So here's some warm water, and then what am I going to put in the other one?
Ice, if you want it to be cold.
So here's ice and warm water. And then how many cups need to go in each one?
Probably 2, because you have to have the hole in the skim, right?
A cup of skim and a cup of whole. And then a cup of skim and a cup of whole that goes in the ice. And you could blow them right away, and then you could let them come to temperature. That's where you could use your thermometer to ask, what is the actual temperature of these? So the cool thing about this is having the creativity to come up with possibilities, and then having the ingenuity to come up with ways to test those ideas, those hypotheses. So Liz, should we ask people how people spell scientist and how we spell scientist?
Sure.
Well, how do you spell scientist?
Oh, we're both gonna bust out our signs at the same time.
Yeah. So that's the normal way to spell scientist. This is the standard way. Everybody gets you 100% on a spelling test. But what do you get if you take the second I and make it into an E? What do you get if you take that second I and make it into an E? You get scientist. And to us, that's one of the key things about what scientists do. It's great to have ideas and collect data and all that stuff, but what we're doing is trying to test competing ideas in a fair way so that we can sieve through, so we can, using data and if then speaking and thinking, arrive at, well, of these ideas, of these possibilities, this one fits the data better than the others. This one is more robust. This one is the one that we can go with until we get better data if that supports a different idea or hypothesis. So there's other ways of doing science, but that's what we can do with this one, with which makes better bubbles, skim milk or whole. One last one, how do you know, how do you test that you're actually blowing the same amount of air into both cups? Well, let's do that if then thinking and speaking again. Now we're asking, is there a difference between the right side of my mouth and my left side of my mouth when I'm blowing? Let's imagine we're running a 100-meter dash in the track. And would it be fair if one person was running on a nice smooth surface and another person was running on gravel?
No.
So we want to run on the same surface. So
and we only have about 1 more minute, so.
All right. This time, instead of doing skim milk and whole milk, we're going to put skim and whole into this, skim into both of them. Because if I'm blowing the same amount of
air
into both, then they should come up at about the same rate.
Okay.
This is like batting averages. If I'm going to do it once, that's great. The one on the left came up a little more this time. I'd have to do it 5 or 10 times, but this is how you can test, am I blowing the same amount of air into both straws?
You also just could get rid of your mouth entirely and just use like a pipette bulb, and then it would be the same amount of air being pressed in every time.
But you'd have
that would be really cool.
Yep.
Well, I'm afraid our time is out, but I do want to thank everyone for joining us, and thank you both Liz and Tom for presenting today. A recording of the field trip is going to be available, and we'll follow up with teachers about that. Remember that the Science Festival continues with events hosted from organizations across the state that you can participate in. So just check out wisconsinsciencefest.org for more fun science. Thank you, Liz. Thank you, Tom.
Absolutely. Thanks for letting us be here.
Talk to you soon.